So this one, I'm sure that everybody's looking at and saying, oh, that's so blind. Okay, we want to try and solve for x. This is called a linear equation, okay? And of course, all of you are aware that what we have there is that x is equal to, when we subtract 1 from the other side, we get 7. Now, that's the kind of thing that we started preparing you in grade 8 already, okay? Now, what happens if, however, I take something like x plus y is equal to 8? Now, can you see that now what I've done is I've introduced a second variable. It's still linear, but now I've got to solve for an x and a y. Now, can you see that where this one here had a unique solution, the only thing that made that equation true was a 7. Whereas here, can you see that you have a whole family of solutions? So, for example, x could be 1 and y could be 7. Or x could be 2 and y could be 6. Or in fact, x could be 3 and y could be 5. And I could go on like this forever and a day, choosing combinations of x and y that added to give me 8. Okay? Now, what we did last year is we showed you that by introducing a second equation, so let's say we took x plus y is indeed equal to, whoopsie, is equal to 8. And in addition, we took 2x subtract y was equal to 13. Oh, this thing is really all over the place, is equal to 13. Okay, so what I've got here is what we call a system of equations. I've got x plus y must come to 8, and 2x subtract y must come to 13. Now you can see that if I actually took that solution 3 and 5, which would have worked here, 3 plus 5 does give me 8. But if I try to use it in the second equation, 2 times 3, take away 5, doesn't give me 13. So although it works in the first equation, it doesn't work in the second. So what I'm wanting to do is I'm wanting to solve these two equations at the same time. So I want to find a set of solutions that actually works for both, okay? And the big fat fancy word for that is simultaneously. Okay, so those of you who are adding to your vocab, simultaneously just means at the same time. All right, so in grade 10, we actually would have taken, just to scroll up, let's see where we're going to scroll up. Let's go back there. It's not going to work. So what we would have done is we would have taken our x plus y is equal to 8, and we would have taken our 2x subtract y is equal to 13, and we would have looked at these and scrutinized them and seen which one is it easier to get x or y isolated, okay? Now, if you have a look at this first equation, I'm going to call it equation 1, and I'm going to call this one equation 2. Equation 2, purely because it's second, and also because there's a 2 in front of the x, which makes it a little bit more difficult. Now, what I'm going to do is I'm going to take my first equation, all right, and I'm going to get it in the y form. So this tells me that y is equal to 8 subtract x. Now, it's exactly the same equation. I've just reorganized it so that I can now take it and substitute the first equation into my second equation. Okay? So I'm going to put 2x subtract the new value for y, which is 8 subtract x, and put that equal to 13. Okay? Now, if I just take care when I multiply through, of course, these are the skills that hopefully have been drilled into you in the lower grades. So I'm going to get a positive x and then equals 13. And you can see now that I'm going to get 3x is equal to 21, and x lands up being 7. Now, knowing that x is a 7 now allows me to go all the way up here and to say, all right, I know that you are a 7, all right? So that means that I've got 7. Okay, doesn't quite like the color pen I'm using, so I've got 7 All right, add y must come to 8, and so y comes to 1. Now that was just a quick recap of the kind of simultaneous equations that we did in grade 10. But now can you see that this one here was linear and that one there was linear as well, meaning that the highest exponent in either of those two equations was a 1. Okay, so now what I'm going to do is I'm going to quickly get down another one, which is purely grade 11, and it's going to have a linear and a quadratic. So let's take y is equal to, this pen doesn't like me today, I'm not sure why.
I don't think it's personal.
Oh really?
It's definitely not personal.
Possibly it just doesn't want to clash. It doesn't want to clash with my colors that I'm wearing. That's the problem.
Yes,
right.
such a
Y
beautiful
minus
blue.
2x is equal to negative 4. I think possibly when James dropped the pen, he's loosened the nozzle. But
Yes,
we'll
blame it on James. We'll blame it on James.
We'll blame it on James.
Yeah.
Okay. All right. So this is my system of equations, mindsetters. I've got y minus 2x is equal to negative 4. And I've got x squared plus y equals 4. And my instruction would be to solve simultaneously. Okay? So that's what we want to do. We want to find the unique solution that makes both of these equations true at the same time. All right, so what we want to do is follow exactly the same steps that we learned in grade 10. We want to look at our equations and we want to see which one is it going to be quite easy to get x or y on its own. Well, I'm going to take the first equation just because it's on the top level, and I'm going to call it my new equation 1, all right, after I've called this 1 and I've called this one 2. Okay, so if that is my original equation, if I'm going to get it into the y form, I'm going to say that y is going to be equivalent to, and of course, I'm going to get 2x subtract 4. And that's my new equation 1. It's just had a bit of a makeover, okay? Same equation, I've just reorganized it so that it's useful for me. Now what I do is I take that and I substitute 1 into 2. Right, so just following quite systematically, I've got x squared and now I'm going to substitute y. Now, I just get into the habit of whenever I do a substitution, I put it into a bracket. Of course, if it's after a plus sign, it's really not going to have any effect. But if it was after a negative sign, then of course the negative would have to be distributed in. All right, so what I'm going to get is x squared, add 2x, and then I can see here that I've got a negative 4, and from the right-hand side, I've got another negative 4, so I'm going to get negative 8 is equal to 0. Right, now what we're doing is we're tapping into what Natasha did in the previous lesson. We're going to have to solve a quadratic equation, which makes sense because one of our equations was quadratic. Okay? So what we want to do is we want to create two brackets, and we want the firsts in each of the brackets to multiply together to get me to x squared, and then my factors of 8. Now, fortunately, 8 is either 1 times 8, all right, or 2 times 4. And I'm sure that you can see I'm going to be able to use the 4 times the 2, and to get a positive 2, I'm going to need a positive 4 together with a negative 2. All right, then obviously the two solutions for x are going to be x is negative 4 or x is 2. Right, now you would think, phew, I'm done. But in fact, I'm not done because I've got x's solutions, I don't have y's solutions yet. Okay, so let's see if we can get back our pink pen again. And remember that our expression for y, all right, was y is equal to 2x subtract 4. Now remember, this was my new equation 1. I could substitute back into my old equation 1 or my old equation 2, but always if you choose your new equation 1, it's going to have the variable that you're looking for as the subject of the formula. Okay, so I'm going to get either y is 2 times negative 4 subtract 4, or I'm going to get y is 2 times 2 subtract 4. So from this side, I'm going to get y is equal to negative 8 subtract 4 is negative 12. Okay, and then here we're going to get y is equal to 0. Now, when we get one of these answers, I like my candidates to put them as a coordinate pair. So that means that what I would get here is I would write when x is 2, y is 0. And here I would say when x came out being negative 4, y had to be a negative 12. And guys, if you had to put these two answers back into your original equations, those would be the two unique solutions that make those equations true at the same time. Another set of simultaneous equations, and all I've done is I've tried to scare you with brackets, okay? But if we have a look at the two equations, can you see that this one is definitely the harder of the two? So I'm going to call that equation 2, and this one is definitely the easier of the two, and I'm going to call that equation 1. Okay, and of course they've been a little bit sneaky because they've even given them to me in an upside down fashion. All right, so now what I'm going to do is I'm going to say from my equation 1, my new equation 1, I'm going to reorganize it, and this time I'm going to get y on its own, and so you can see that y is going to be negative 2x subtract 1. Now, of course, Franz is most probably saying, could he have isolated the x and divided by 2? Well, yes, of course, but then he would have been working with fractions. Now, the next question is, do I have to multiply this out first? Well, no, because look at what I can do. I can just say I've got x subtract 1 squared, and I've got y. Now, y is going to be replaced with a negative 2x subtract 1. Then I've got my subtract 2 that was there originally. So this is my bit here that's being substituted for y. And then I've got that squared is equal to 5. Okay? Now, of course, it's just a matter of doing all the algebra crunching. So we're going to get x squared, subtract 2x, add a 1. And then here, before I square out, I think it could be quite good for me if I just quickly add my like terms in here. So I've got negative 2x, subtract 3, squared comes to 5. Right, so x squared minus 2x, add 1, subtract, I'm going to then have add. I wasn't following my basic rules. I must obviously square out first, and so when I square out, I'm going to get a positive 4x squared. Then I'm going to get a positive 12x, a positive 9, and I'm going to bring my 5 over at the same time, because as Natasha said in the previous session, the minute that you see you've got x squareds, you know that you're going to have to apply that rule of 0, that you're going to have to get a product to come to 0. Okay. Let's have a look at where we are now. We've now got x squared minus a 2x plus a 1, okay, plus a 4x squared plus 12x plus 4 is equal to 0. And that gives you a 5x squared, and it gives you a 10x, and it gives you a 5 is equal to 0. And at this point, one of three things can happen. Either you might need to take out a common factor, which is very clearly what I can do here. All right, and so what I get left with is a very nice, easy trinomial. Or, of course, you might need it to have gone off and done your trinomial factorization. Or it might not have factorized, and in grade 11 that's possible, and you might have needed to have used your quadratic formula. Right, so here, of course, what we recognize is that this is actually x plus 1 squared, because it is a perfect square trinomial. And, of course, now, and I say of course, but many candidates want to know what happens to the 5. Now, remember that if you've got a 5 out there, what you technically do is you can divide through by the 5 on each side, and so you are just left solving x plus 1 squared is equal to 0. And that is just, compare that to this situation, guys, because it's these kind of things that trip you up. If the 5 had an x as part of its factor, then of course we would have 3 solutions here. We would actually have to introduce x is 0 as one of the solutions coming from there as well. All right, so finally here we're going to get x is negative 1. And of course, it could be negative 1 again. So there's only one answer. So I've shown you that, in fact, even although originally it was quadratic, there's only one answer for x. And of course, guys, you're then going to go back and you're going to substitute for y. And that's going to be pretty easy. And you're going to get y is equal to 1. I've got a second quadratic together with a linear simultaneous equation, which we're going to take you through. But I thought that maybe what I could do is give those of you who are able to multitask, I'm going to give you a challenge. So this is another system, x squared minus 2xy minus 5y squared is equal to 3. And x subtract y is equal to 3. So this is going to be your challenge, and what we'll do is at the end of the show, we'll just give you the answers for that one. So while we're at a break or whatever, that's where you can get your teeth into it. Okay, so let's focus on this one here first. So again, your instruction would be to solve simultaneously for x and y. So if I have a look at my 2 equations, I think that here it becomes very, very clear that it's much easier to get x on its own than anything else. So here we have our first equation, and here we have our second equation. And I just very quickly want to make it clear that when I wrote that down, there was a blips. Oh dear. And now another one. Okay. This squared is not meant to be there. Okay. So there we go. It's just meant to be a 2x plus a 5y squared minus 57 is 0. Okay, so now you've got the picture. We look at the first equation and we identify that we can actually make a new equation out of it quite easily. And so the new equation is going to read that x is going to equal, all right, positive 18 subtract 4y. And you can see that I've organized it just so that it's a bit more user-friendly. I've got my 4y at the back rather than having it at the front, but that's just a kind of a personal preference. All right, so now remember my next step is I'm going to substitute this equation 1 into my second equation. All right, so I've got 2, and I'm multiplying in by x. All right, so this x gets replaced by its substitute. Okay, so those of you who play sport, if you get injured and a substitute gets sent in, they do the job for you while you recover, and then eventually, you know, they go off the field again. So all that you're doing is you're substituting an equivalent value for x. So 2 times 18 minus 4y minus 5y squared subtract 57 comes to 0. Okay? Right. I've got 36. All right, subtract 8y, add 5y squared, minus 57 comes to 0. Okay, let's see if we can try and extend this page. We don't have an extending page down here. So let's see if we can perhaps do something. Okay, let's drag it down. We'll try and scroll.
There's extend the page.
There it comes.
There's
Okay.
extend the page.
So now what we've got is we've got 5y squared. Lost the pen again. So now we have got 5y squared Okay, we have got negative 8y, we have got negative 21, and that comes to 0. Okay, now once again, guys, if your factorization of quadratics is a bit shoddy, this is where it's going to come in. Now, I know that Natasha mentioned that some of you have got calculators that can do this, but of course, if you haven't got a calculator, you're going to have to go off and somehow manage to trinomial factorize that into our two brackets. All right, now, on the one hand, you can be quite happy because 5 is just a prime number and it can only be as a result of 5y times y. Now 21 is also quite a nice number, although it's not prime. It's got the factors 1 times 21 and it's got the factor 7 times 3. Now it's a case of taking your best guess, and I normally encourage my candidates to go for the factors that are closer together. So I am going to try 7 times 3. So my factors of 5 are underneath each other, my factors of 21. Then what you do is you cross multiply. So if you take 5y and you multiply it by 3, you get 15y. And if you take 7 and multiply it by y, you get 7y. Now you need to have a good idea of how the numbers need to multiply by each other. Can you see that the back sign is a negative? And so that means that you've got to select two signs that are different. And as a result of combining these two, we need negative 8. So the only way we can do that is to have a negative 15 and a positive 7. Now this sign, whatever it is, be it positive or negative, it gets put into the top level and it creates the first bracket, which is 5y add 7. This sign goes onto the bottom level and we now have y subtract 3. Now you can see quite clearly that what we have is just to solve for y, and we get y here is equal to negative 7 divided by 5, or we get y is equal to 3. We had y was equal to, thank heavens I did jot down some notes before, we had y is equal to negative 7 over 5, and we had y was equal to 3. So I was about to say that you must not always expect nice integral numbers. So if you get numbers like 2 and 4, that's a bonus, but sometimes you're going to get fractions, all right? And in fact, sometimes in grade 11, you might need to have used the quadratic formula on that first equation as well. Now, of course, what you have to do is you have to then get your x values. And if we recall, our x was 18 subtract 4y. So that is still visible for me, which is great. So 18 subtract 4y. All right. Okay, so what we've got is 18 subtract 4 times negative 7 over 5. Okay, and then the other solution will be x is equal to 18 subtract 4 times 3.